back. Sorry about my last video. I didn't realize that it was going to show that PDF on the side as well. I thought it was just going to be my document camera thing. So it's kind of small. I apologize about that. So here we go. Alright, so like we talked about in our last video, we talked about how we choose the x values. And the best way to choose those x values typically is to have a good even spread across the origin. But sometimes using -2, -1, 0, 1, and 2 is not the best choice. So when we have a denominator or a fraction in front of our x value, we're going to want to look at what that denominator is in order to choose the best x. So, to choose the best x, look at the denominator. And when we look at the denominator, we want to choose multiples of that denominator. And we want to at least have 2 negative values and 2 positive values. And then we also want to include 0. Okay. Alright, so if we are going to create a table of values that are going to fit this equation right here, see this number. I know it's a fraction. Crazy. Let's take a second. We can do this. Fractions are awesome. The denominator of this fraction that is being multiplied to x is 7. So we're going to want to use multiples of 7 for our x values. So let's remind ourselves what the multiples of 7 are. 7, 14, 21, 28, and so on. Okay? But remember, we want 2 negative values and 2 positive values, so we want 0 in the middle still. I'm going to set up our t-chart. We have our x values here, and y is 1/7 x plus 2. Okay. So when we choose these, we want 0 in the middle, and we're going to use 7 and 14, and then -7 and -14. Alright. So I know these numbers look a little bit bigger, it's a little bit scary, but it's alright. Because we are choosing multiples of 7, that fraction is going to go away, and it's going to be a nice pretty number. If we were to choose -2 and -1, we wouldn't get pretty numbers. So we have 1/7 times -14 plus 2. So I'm still substituting in. The 1/7 won't change, and the plus 2 won't change. Alright, so when I multiply those, 7 goes into 14 twice. So this is really -2 plus 2, which is 0. Nice pretty numbers. Substitute -7 in. 7 goes into 7 once, so when that cancels out, we really have -1 here. And -1 plus 2 is 1. Now we have 1/7 times 0 plus 2. And anything times 0 is 0, plus 2 would be 2. Now, if you remember on our second equation from the first video, we talked about the consistency, those differences. What are we going up or down by each time? So here, we went up by 1, and here we went up by 1, and over here we went up by 7, by 7, by 7, by 7. So since we're consistent in our x values, our y values are also going to be consistent. So from here to here, if we add 1, we have 3. From here to here, if we add 1, we have 4. Okay. So when I go to make my tick marks on my graph, I don't know why I made the y-axis so big. I really should have made the x-axis bigger. But it's alright. We'll work with it. Okay, I want a lot of tick marks on my x-axis because I have to go all the way to negative 14 and positive 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Whew. That's pretty amazing. It's awesome. I didn't think I was going to fit 14 on there. Let's see if I can get 14 on the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Man, that's good. And then my y values, I only have to go up to 4, so I can spread those out more if I wanted to. 1, 2, 3, 4. All right, let's graph. Runaway marker. My ordered pair is, I don't know what I'm pointing to, negative 14, positive 2. So from the origin, my x value is negative 14. I'm going to go to the left 14 and up 0. Did I say 2? 0. I have too many numbers written over here. Negative 14, 0. So on the x-axis, I'm just going to plot my point. My next ordered pair, negative 7, positive 1. So from the origin, I'm going to go to the left. 1, 2, 3, 4, 5, 6, 7, up. Oh man, I lost it. 1, 2, 3, 4, 5, 6, 7, up 1. And my next ordered pair is 0, 2. So from the origin, I'm just going to go up 2 because my y value is 2 and my x value is 0. Next, I have 7 3s. So to the right, 1, 2, 3, 4, 5, 6, 7, up 1, 2, 3. 14, 4. So all the way to the end, up 1, 2, 3. Draw your line through the dots, not to the dots, through the dots with your arrows on the end. I feel like I hyperventilate when I'm making these videos and I breathe really heavy and I'm really sorry about it. All right, our next equation. Another fraction, and this one looks even scarier, so I'm going to take a second, freak out. Let's go. Okay. Looking at this, we want to look at that number that's being multiplied to x, and we want to look at the denominator to figure out what our best x values are. The denominator of this is 5. So the denominator is 5, so we want the multiples of 5, and the multiples of 5 are 5, 10, 15, 20, 25, 30, so on and so forth. We want 2 positive values, 2 negative values, and 0 in the middle. Creating our table. We have our x values, and our y value is going to be 8/5 x minus 8. So if we want 0 in the middle, and we want 5, 10, then we want negative 5, and negative 10. All right, let's substitute in. See what happens. 8/5 times negative 10 minus 8. So 5 goes into 10 twice. We had a negative. 8 times negative 2, 8, 16. So we have negative 16 minus 8. And negative 16 minus 8 is going to be 24. Yeah, negative 24. All right, let's do the same thing here. 8/5 times negative 5 minus 8. 5 goes into 5 one time, and we have a negative. So it's 8 times negative 1, so that's negative 8 minus 8. Same sign, add the numbers, keep the sign. 8 plus 8 is 16, keep that negative sign, negative 16. 8/5 times 0 minus 8. 0 times anything is 0, So it equals -8. I'm going to write it way out here just so it's even. We have enough information to start to see our pattern if we want to. You can definitely simplify the whole way through and you're going to get the same thing. From -24 to -16, we add 8. From -16 to -8, we add 8. So from -8 to our next value, we're going to add 8 again. And from here, we're going to add 8. Alright, so my tick marks, I'm going to have to go to -10 and +10 on the x value. My y value goes all the way to -14. So I probably should have had that last graph on this one. I don't know if I'm going to get to -24. Did I say 14? I think I said 14. -24. But I'm at least going to try to get to -16. So this might be one of those where you look at it, you're like, oh, that's really far away. Maybe I should do the next one. And you could actually you can add points at any time if it's going to make your life easier. Let's add the next one, which would be 15. To add 8 to that would be 16. So I'm going to rewrite our ordered pairs just because they're kind of scattered all over the place. So I have -10, -24. And again, that's here, 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 -5, -16, 0, -8, 5, 0, 10, 8. And then the one we just added, you don't have to add it, but sometimes it helps. Because now I'm going to try to make my graph go from 16 to 16 on the y-axis and 10 to 15 on the x, -10 to 15. Arrow, arrow, x, arrow, arrow, y. Right, so I don't think this is going to look very good. It's okay. It's alright. Homemade graph. It's not going to be pretty. Alright, let's graph. So, -10, -24 would be like way down here. -5, -16. 1, 2, 3, 4, 5. Down to 16. 0, -8. 1, 2, 3, 4, 5, 6, 7, 8. 5, 0. 1, 2, 3, 4, 5. 10, 8. 5, 6, 7, 8, 9, 10. And 15, 16. Okay. So it's not the prettiest because we don't have any computer generated graphs. You could also change your scale, which I probably should have done, but you can change your scale to go by 2s or 3s or 4s or 5s to make it to have more numbers in a smaller space. But we're going to make it work. Ooh, this might be my worst one yet. No surprises there though. We're line through the dots. That's ugly. Anyways, there you go. There you have it. Alright, let's compare a little. So those are the two graphs with fractions. And those two graphs are with whole numbers or integers. Now, this isn't the best comparison because they're on homemade graphs, but if you have a fraction coefficient, like we did here, your line's going to be flatter. And if you have a whole number or an integer that's not a rational number, your line's going to be steeper. It's not that bit important. That'll come into play later when we talk about parts of the line. But right now we're just looking at the equation and we're creating a table to graph because we know how to graph points, we know how to substitute values in, and we know how to solve. All right. Stay tuned for my next video when we look at problems that are written a little bit different than this.